Good morning. We're going to go over a few ways to implement standoffs and create a ladder system that you can use on this year's robot. So for this year's robot, one of the first ways you can use it is in your gearbox. So this is part of your drivetrain, or it can be used elsewhere too. So if you look here, you can see the system of standoffs that create a ladder, and the ladder creates consistent parallel spacing between the beams, which is very important, so that when the gears spin, there's never any pinching on them. That's really important. And this is a cool STEM lab that Bex does, and it's used to show how gear ratios can enhance motor performance. So if you haven't done this one yet with your kids, it's super cool. Another way a ladder system can be implemented is in the tray. So the tray for this robot was used to dump robots into the goals. So the blocks come over here and just go downwards into a tray. The reason this ladder system was important is because it was lightweight. So by using these standoffs as opposed to solid 2x2 beams or flatter beams, wider beams, is to create less weight so the motors on the drivetrain are stressed less. So making solid structures, which is something the kids want to do naturally, puts too much weight on a two-motor drive. So this is just a way to kind of lessen it up by creating trays. Now, these trays can actually be used with another robot I've seen a lot this year, and that's what I call the elevator robots. So we've seen a lot of elevator robots, but not a lot of trays. So when you're creating the elevator robots, these are the ones that move up and down, and then they dump the blocks into the goals. So you can use these trays at this angle. You'd probably set it up roughly about there, and then when this goes up from the robot, it will then dump the blocks in there. And these are very petite little linear systems, so the less weight the better, because you're putting less weight on the structure, and these will definitely help with that. So one of the things I've seen is the kids worry that this is not a solid piece. It's not flat, it's not flush, there's little holes in it, and that's really tough for some of the kids to get over. So if you can get them to do one and test it out, they'll eventually get the hang of it and learn to start building wisely and with less material, which in the end will put less strain on your motors, help your robot move a little faster, prevent motors from burning out, and be a lot better build overall. That's our video for this week, so I hope it helped a little bit. And oh, one more thing, almost forgot. This robot also used these in the drivetrain, and so that was super handy because it allows the wheels to turn without ever getting pinched. So if the robot starts to warp or anything like that, the standoffs create, just like with the gearbox, consistent parallel spacing between the beams. And that's what it does in your drivetrain. So we went over the gearboxes, the drivetrain, trays, and that's 3 different ways you can use standoffs to create parallel spacing to enhance your robot. All right, that's it for real this time. Thanks, guys.